Good morning, everyone. I'm going to skip past all the marketing stuff. We're going to get right to it because we have a lot of ground to cover. We're going to begin with our chalk and talk overview of what we're covering. The demonstration of fully integrated continuous integration, continuous deployment pipeline to manage AWS infrastructure from Azure using the AWS connector from Microsoft. In the lab session, you will be downloading the code and building your own AWS infrastructure. Now I see I'm recording, but I'm not sharing the display. So it's not going to show up on the recording. Like that. So why multi-cloud? Why would we care to add complexity to our environment? Well, I kind of put this bit of humor up here. Office 365, which begot a small Azure pay-as-you-go subscription, which begot a 3-year subscription for information technology services, and that begot an academic department that wrote and received an AWS grant without checking with ITS, aka Shadow IT, which begot a different academic department who wrote and received an OCI grant, which begot a big freaking mess in cloud spend and security risks. And now someone in IT has been saddled with the responsibility to clean the mess up. Doesn't that just sound like fun? Never been there before in VMware days with VMware Sprawl, or things like Dropbox, et cetera, and so forth. We've all seen it all. So all these different tools, more work, increased risk, but no increased headcount. And that student lab tech who is responsible for setting up the cloud is fighting with you, does not have the proper background or credentials or training, and it's just getting hard to get this mess under control. What doesn't help is that grants have less money for IT positions versus IT organizations. And therefore you're not in lab settings, you're not attracting the IT talent because the money's just not there to pay for good people. Technicians who are hired, they know how to connect the hip bone to the knee bone, aka connect that monitor up to that tablet, but they don't have beyond academic fundamentals, programming skills, or organizational know-how. Grant deployments are snowflakes within the IT organizations, and snowflakes have the tendency to drive up cost and risk. Academic cloud subscriptions are not built with security in mind beyond the basics, and when we talk about research ending up in there, well, the Chinese love you for that. Thank you, give us all your secrets so we can copy them and leapfrog the United States. Cloud spend also gets out of control, and that has the risk of sinking a grant program, research careers, and damaging institutional reputation. Consider this: if you haven't ever written grants, and if you haven't, I would encourage you to do so. The rejection is incredible, but when you finally get it and you finally win, it's very rewarding. It's also very rewarding to your careers. Because people respect you when you bring money into the institution, but it is highly competitive. And if an institution has a reputation for sinking grants, that gets known very quickly, and it gets much tougher to get money going forward after that. That was the situation that I stepped into in Delaware when I initially started writing grants. Was, well, this institution had a reputation for not delivering the goods. And it took a long while with peer reviewers to overcome that. So it's really important to ensure that grant programs succeed. They're not your enemy. They're the lifeblood of the institution, because they're the lifeblood of the institution that bring in more investment dollars, that become a halo that attract future students, that buttress and support post-grad programs. These are all really important stuff. Okay, so enough of that. Let's go on. Managing infrastructure as code offers you the opportunity to control this beast. Without it, and with folks going in and using the UI, you could call that OCI console, you could call that the Azure portal. I forgot what AWS markets their interface as. When you're using the UI to drive this, you're introducing a huge opportunity for human defects to be introduced into this. And by using infrastructure as code, by implementing code peer reviewing, when you do your branch merges, you really begin to get control over this, because many pairs of eyes looking over something versus one pair of eyes means that you have an opportunity to have less defects when the product actually pushes through. Less defects leaking through to the customer is a good thing. An interesting note, when there was a big fight going on between industry and what started out in higher education, the open source mania, research has proven time and time again that open source has less defects in it than commercial software. And the reason for this is the crowdsourcing that goes on with identifying both product defects that are functional or technical, and product defects that are security related. Terraform, a bit about Terraform. Terraform is a declarative language. With a declarative language, you're declaring the entire whatever it is that you're doing for that piece of code. And it has to be syntactically correct from the start to the end. And in a declarative language takes into account and builds everything in the right order at the right moment in time, usually. But there are defects that bleed through, and I will talk a little bit about that, where some of those defects leak through if we have time. We may not. There's a great dependency here on what are called provider modules. And with provider modules come from Microsoft, they come from AWS, GCP, and take your mind out of cloud for a moment. You have provider modules from Cisco, Fortinet, Barracuda, VMware, Dell. All of these major providers have caved, as much as they fought it in the beginning, and now provide Terraform provider modules to manage the infrastructure using Terraform. And that means you can get all of this, even NetApp for that matter, so you can get all of this under control and handle it as an application programmer and develop the full stack. Now even your on-prem firewall and your on-prem routers are part of the code. When I talked earlier, and if you would reference my first session regarding the research, accelerating IT with DevOps and change enablement through release teams. That's some research that I and 3 colleagues from 3 research institutions recently completed. It was published in September. It was peer-reviewed. We talk about in that paper the things that you should be doing culturally in your organization to be successful, to be successful as a DevOps change-enabled organization. So you should read that paper. You should pick up the reference material. Some of it you'll have to go through your academic department to pull it down, because research papers are not, especially the good ones, are not free typically. And there's some books that, of course, that are college texts and things like the Phoenix Project that are referenced there as well. So Ansible can be imperative or declarative. Imperative is what we started out in the industry with 3 GL languages writing, C++, Java, Python, et cetera, and so forth. Those are all declarative, imperative languages. Now, it's interesting to note that languages like Terraform and Ansible are Python wrappers. Therefore, they're all running under the hood. They're all running Python directly to the RESTful APIs. So if you don't have a background in Python programming, you need one. There is a lot of garbage training on Udemy. If you want the good training, hit me up on LinkedIn. And there are 2 courses. You all know by now how bad I am with names of people. So, but it's the same author. One course is in the fundamentals of writing Python, and the other course is in using Python for big data. And both are very applicable to our careers these days, as is AI. I don't know if the gentleman offers a course in AI, so I can't speak for that. Now, Ansible can be used, pardon me? Udemy is the name of the provider of the content. But I will, if you hook up with me on LinkedIn, do a connection request, then I can respond to you with all of the training that you should be looking at on Udemy, because like I said, there's a lot of garbage. There's also some good Terraform training, managing AKS with Azure DevOps. It is Terraform pre 1.x, but it's not too difficult to make the transition to 1.x from 0.x. And it's a cheap course. So back to Ansible. Ansible can be used for declaratively or imperatively. It can be used for management of mutable and immutable objects. However, I would not use it for anything but management of mutable objects in either a declarative or an imperative mode. There are use cases to use Ansible for imperatively, but most of the time you'll use Ansible declaratively. Git repositories are key to this. Now, of course, we know that Microsoft owns Git. There are other repos out there, but GitHub is the gorilla in the CSV management space. I see no reason to use anything else. Microsoft has turned 180 degrees. They are the most open vendor out there in the cloud space that I work with, even more so than AWS. AWS, they're all open source under the hood. However, AWS obfuscates in their documentation a lot of the know-how, and that really pisses me off. Microsoft is, to a certain extent, with their documentation and their online help, a facilitator of knowledge. And they don't do that for altruistically. They do that because they understand the business environment. But also they, you'll use, so all of that spiel is really about, or story, is really about the importance to use GitHub for code versioning. Tools like Terraform Enterprise, they do a few things, or one thing in this case, very well. But HashiCorp, it makes no secret of it that they're not in the business, at least at this time, of configuration management. And yes, there is a marketplace plugin for Azure DevOps for Ansible, which means that you can even look at running Ansible as a container in your Kubernetes cluster and dispense entirely with having a VM for that purpose. That's something I'm going to be playing with Sai, who's over there in the room, at some point next year. Ansible Tower, for those of you who are using it, get ready to get the axe out and slash that beast. That $10,000 a year is not necessary. Yes, sir.
What's your favorite in terms of Terraform and Ansible?
They each has their purpose. I don't have a favorite. So I use Ansible for configuration management of mutable objects, and I use Terraform, and I also use the Kubernetes language, which is declarative, for management of immutable objects. Remember that mutable objects are things that stay in the platform, that don't go away. A most notable example would be an ERP database. But things like the application tier, all those containers that are running your application tier, if you've containerized Banner, then those are immutable objects, which means they don't change when they've been created. They change in the development, the DevOps workflow. But once they get pushed into the form of a release, they don't change. And when you scale out and scale in, assuming that you've got auto scaling enabled, then more copies of that image are spawned based on the logic of your code. And this is done declaratively.
So if I have a team who has good Python expertise, which Ansible is totally relying on, and HashiCorp programming language that's completely new to the whole team. So, but again, I mean, what would be the learning curve for HashiCorp programming language if I need to go with Terraform? How complex it is?
The learning curve is about 6 months. It is. And a lot of that has to do with the fact that the provider modules are, in my personal opinion, inadequately documented. And AWS is just, I want to pull my hair out every time I have to work with their modules, because their response is, oh, here's GitHub, here's the code, go figure it out. And that's not nice. And what that is that is going to bind you to their professional services. That's the whole point, is to sell more services. That's why, in my opinion, the documentation is not right. Microsoft is a little better, but Microsoft also has a much larger community on Stack Overflow and other forums. At this point, I don't even go to the blobs, because the blobs are just a waste of my time. I used them initially. I would recommend, once I found the good Udemy training and went through it and had frustrating weekends, Now, once I mastered it, then I don't go to the blobs anymore because they're just a waste of my time and they're also inaccurate in many cases. So I hope that helps you. All right, so let's move to the next slide. Why would I want to use Azure DevOps to rule all the clouds? No pun intended to Lord of the Rings and Tolkien. It's a robust development platform. It was originally called Visual Studio Enterprise, but was rebranded to Azure DevOps. But when you really look at it, if you have Visual Studio Enterprise experience, you'll be very comfortable in Azure DevOps. It can be installed on-prem, but I would say that that only makes sense for the Fortune 250, even that is questionable. You do have to, when you set it up, it initially sets up with one concurrent microservice running at a time. So if you're running multiple pipelines, you do have to scale that up. That's just done in the global settings when you set up your project or your organization, I should say. The cost is $0 for the first 5 seats. Each additional seat, which is an identity in Azure Active Directory, costs $6 a month. You tack onto that $29 a month for your developer support, for your development subscription, and there you go. You got everything you need. Now, I will offer a very important comment here. I cannot underscore this enough, especially since cloud salespeople don't get it. You need to have at least 2 subscriptions in your organization for the target subscription, regardless of the cloud provider. So if you've got AWS and Azure, if you've got Azure and OCI, you need to have 2 OCI tenancies and 2 Azure subscriptions. Why? Because you'd be crazy to write code and test it in a production subscription. That is a resume writer. I'm not changing my code. The only thing I'm changing in my code is what the block that references the subscription name or ID and the block that references the storage account where I'm going to save my Terraform state. Everything else is going to stay the same. When I'm working on something that's really intense, I have a pipeline that runs, that'll be running on a schedule, and I'll sign on my computer in the morning, and my development environment, my cluster, and everything that I need for that project has already been built before I'm even signing on. And then I have another scheduled pipeline that runs at night that tears it down in case I forget to destroy it. And what this means is I keep my development costs down to a few dollars a day. And then I can just disable those pipelines when I don't need them anymore. End-to-end visibility of all deployments from a single pane of glass. That's great because you get the stats, you get the analytics, you get things like a Kanban board where you can increase collaboration in your organization. And if you start using Azure, if you start using DevOps Kanban board, you'll know what I mean. It's just so collaborative. It's great. And I would love it if we could use that to collaborate with our clients, but you guys are not there. But that's why I'm here today, to help you get there, because a more educated client is better for us and it's better for you. Okay, so configuration management of mutable infrastructure using Ansible Marketplace extensions for DevOps. What is that? That is a, let's talk a little bit about what DevOps is, Azure DevOps. It's a microservice that launches. You know, you got the whole back end, of course, all the code behind that, but when it actually executes a development pipeline, that's your continuous integration in CI/CD. So when a development pipeline loads, it starts an agent, and you define whether that's a Linux or a Microsoft agent in your code. Then it pulls the code from the Git repository. Then it builds the artifacts. Based on how you write your code, it will or will not run tests. And then it exits. You marry to that. Now, mind you, in some training, then the trainers take you on to actually do deployment from the development pipeline. That's a no-go to me. That's a job killer. And the reason why that's a job killer for me is because you're taking out your approval and your scheduling by doing it that way. Now, in some of the training I'm going to be referencing to you, for the Terraform training, the trainer doesn't do a release pipeline for the terraforming, but does the release pipeline for managing the pods on AKS. I don't get that. I'm going to be filling in those blanks. I'm going to show you how to marry the two. The Microsoft documentation is really a setup to pay for professional training and professional services. You're getting it cheap here today. Okay? So you won't need to pay for all that crap. But you want to marry the development pipeline to the deployment pipeline or the release pipeline, because that release pipeline is where all the magic happens that your bosses are going to love and that you're going to love, because it's going to allow you to wrestle this cow and get it under control. Okay, so Jenkins has service hooks that can be built to trigger from applications that are running a Jenkins engine. Think ESM. ESM is just a rebranding for Jenkins. That's what it is. So, and we just recently did that for a large school, and it's really cool because now you're not dealing with, you still have some custom scripts that are going to be on the ESM machine, but the actual building of those images now occurs within a development pipeline in Azure DevOps instead of on the imaging machine. Someone from SIG was bragging about how to do this, and I fell off my chair laughing, because why would you want to build it like that, to build the image where you can't see everything, where there's no transparency? You don't want to do it that way. That's wrong. The right way is to build the image in DevOps so that you can see everything and you can see all of the release history. Okay, so also possible to manage other clouds such as OCI and the IBM clouds, but you have to build an agent custom connector, and that's not a trivial matter. We classify it as cheapware, and we already talked about what those costs were. What will Azure DevOps not do for me? It will not help you to learn your cloud provider technology. It will not help you to learn the cloud provider plugin modules. So I like to quote someone in our organization. You all probably know who Rel is. And Rel is, you know, he, by all measures of the word, he is a code head. And he likes to say when someone in leadership gives him some pressure, myself included, well, Hank, I need 30 hours to figure out how to do that thing that takes only 5 minutes to do. Well, guess what? Welcome to the world of provider plugin modules where nothing is documented. Stack Overflow can be your friend here, but what if you're first? And sometimes I'm first. And it's interesting, when I was first, I actually posted a solution for which a question had not been asked. And the site administrators rejected that post. Go figure, man. Go figure. But Stack Overflow is your friend. Put your questions there. You may get an answer that's right. You may get an answer that's wrong. You may not get an answer. But at least you have a shot at it. Of course, with developer support, it's break fix only. So if it's how to, well, we have a professional services division for that. But we have a strength in the higher education community. We're very collegiate. So we can bust through that crap by working together. Writing code will not, writing code is central to this. It's a UI, but if you can't write code, then get out of the chair. And finally, this will not help with strategy and process. It's a tool. Back to the research paper I was talking about before. The biggest mistake an organization can make is to pick a piece of technology without a strategy and without a vision. That's how you incur technology debt. That's how you create organizational entropy, toil, waste, and employee dissatisfaction. Does everyone here know what containerization is? Anyone not know what it is? Okay. So you got various engines out there. I don't know about this OpenVZ and Sandybox stuff. Kubernetes is it. Again, as I had indicated in earlier lectures, Docker Storm is a great teaching tool. It is great for you to teach yourself how to do this because it has less complexity. Conversely, it has less flexibility. And that's why I don't care for Storm anymore. Why is that the case? That's because the big cloud providers got tired of paying all those license fees. So they formed a consortium with a few higher education institutions to create something else, and that something else became Kubernetes. And actually what was Kubernetes was in the works for a long time. It's just that someone at the big cloud providers saw it and said, this is it. This is how we get out of the license fee box. Now, what's the advantage of this? The advantage is you got all that knowledge power building behind this. And it's a momentum that I don't believe Docker will ever overcome. They're too late. They didn't see it. And of course, Docker did the FedEx and UPS thing, which is, oh, volume has gone down, raise your prices. So now if your organization has more than 25 people working in it, you're required, according to the license terms and conditions with Docker Desktop, to pay a fee. You can get around that by using the CE edition. I'm going to show you how to do that.
My understanding is that is for large organizations. In my case, my organization is in a small size, so is that any like minimum, like recommendation to use Kubernetes? I just don't want to add complexity to my environment if it will be again.
I disagree with the thinking. Kubernetes should be it regardless of your size. And that's because the cloud providers are behind it. So I can go to one of the second or third tier cloud providers and it's still Kubernetes, no matter where I go, no matter how small it is, no matter how big it is. So why would you have multiple node pools? The use case for ERP systems is to employ a blue-green model. A blue-green model is one where you've got your application running on blue and you push out a new release to green and you gradually move users over from blue to green and vice versa when you do your cutover. It doesn't always work that way if the application is not designed for that, like Banner. Banner is very legacy, so it's more abrupt. But you're still going to do a quasi blue-green or a modified blue-green model where you'll have your node pool at version X, you'll have your node pool at version Y, and then you'll move your pods over, which basically stops them and moves them from X to Y. But you leave X running in case a defect is discovered in Y and you need to roll back quickly. For cloud native applications that were developed from the ground up as cloud native, you can handle the blue-green deployment all within Kubernetes using Kubernetes load balancing. But what we have found with Banner, because Banner is very old from a coding perspective, very legacy with how it manages cookies, that you have to move the load balancing logic outside of the cluster in order to have resiliency and scalability. And that really has to do with big retail or e-commerce and how large e-commerce has to scale. The way that cookies are managed in an application like an ERP, a legacy ERP, just doesn't scale to the way that retail needs. So your Kubernetes container plugins that plug into the Kubernetes on a worker, on a node pool, they do not support the type of logic that Banner requires with these jar files when they start up for cookie stickiness and session persistence. Okay, let's eliminate the marketing from the room. Any marketers, you may not enter through those doors. Orchestration is a form of automation. Orchestration is critical to managing your cloud. If you're not orchestrating your cloud, then you're not being efficient. If you orchestrate correctly, you're exploiting cloud elasticity. Your cloud salespeople will not help you to exploit cloud elasticity because it cuts into their margins. And what cuts into my margins cuts into my paycheck. With orchestration, you can define how that elasticity is exploited, and you can implement scheduling, and you can integrate tasks between different parts of the platform. Remember, in DevOps, we consider the entire platform to be the solution. So when we look at lean, applying the principles of lean manufacturing to IT, then it's the building, it's the technology, the data center, the cloud providers, the networking, the people, and the software. And the processes, the practices, the documentation, all of that is part of the platform. It's a different way of thinking. Typical automation tasks are done declaratively. Why? Because when you do it imperatively, you have to consider every condition in your logic. And then if something fails, then your logic has to account for that. So when you do this declaratively, then it's on the provider module to handle that. That doesn't always work. And you have to know, usually it's the school of hard knocks that tells you that, all right, I got to do this one declaratively. Case in point, I've got a script that runs that does log file grooming. Very useful for when Ellucian comes out with new code and they leave advanced debugging turned on for Apache. Think 8.5.53. They just did that. Thank you. Something like that is better done, is better suited for imperative versus declarative. Regardless, you can still orchestrate all of that. And you can orchestrate all of that with Azure DevOps and get out of the business of all this cron crap. Because with cron, then you don't see it. And installing cron D on your containers and your operating systems is an attack vector. And the recent WSO attack that occurred in April and then occurred again in September, and the crypto mining attacks, and like what I talked about 2 days ago, which was really just a facade to hide what they were really doing, which was trying to break into your stuff. Oh yes, so with all of that was using cron and taking out cron, deinstalling cron where you can. You can't in every case, like the virtual machine database in OCI, you cannot remove cron, you've got to leave it there. So you got free community editions for all this stuff, but you're going to end up in the cheapware versions, which are credit card only, and of course, you've got to deal with educating your finance department on that, because they don't like credit cards, they like POs. But they'll get over it. So if you're not a lab rat and you're here, you should be. What are we doing today? We are going to be doing code development of AWS EK. That's E is Elastic. That's part of their marketing. So it's an Elastic Kubernetes service. They're all Elastic. Let's get real. We're going to be using Docker Desktop, AWS CLI. In an Ubuntu container running on your desktop. This is going to be easier for you if you're on Mac. If you're on Windows, you're going to have to go through more hoops. And we're going to launch that container instance on your desktop, and Terraform will be installed within the container instance, and persistent storage, a persistent storage mount, will mount your code on your local machine. Of course, that code will be managed with Git. We're going to talk a little bit about branching. We don't have time to do it, but I will show you where to go to get the branching strategy. We'll talk about some branching strategies, and we'll talk about where you can learn how to do the branching, how to create a release branch, how to create a development branch off the release branch, how to push that code back to the release branch, and then eventually how to merge that into the master branch. Because when the master branch triggers, or the main branch, that's what triggers your development or your integration pipeline. And then it all flows from there. We're going to do a fictitious production push to AWS within Azure DevOps. And you will get to build it. I will guide you through it. This is the technical architecture for the solution or the platform portion of the solution that we're building. We're not really building an application. We're building we're building one VNet, 3 subnets within that VNet, and then we're building out the AKS cluster. The purpose of the training is to give you the fundamentals. We're not going to have any scope creep beyond that because would take too much time. Let's talk about the caveats. Terraform modules are reusable modules that use the provider plugins. They are as good as the provider plugins. Now, some of you have heard me say already, I don't like the open sourciness of AWS. And what do I mean by that, since everybody is using open source? What I mean by that is the culture that results in the documentation for the AWS provider modules is very open sourcey, which means that I've got to go through the pain to figure it out. It's a lot cleaner with Oracle, and it's a lot cleaner with the Azure plugins. This is why big schools are willing to pay for multi-cloud, because they want the maturity of the business tools and the documentation and the support structure that exists within Microsoft. I don't think AWS cares to do that because they're more focused on retail. Although they are focused on getting business to business, they want it all. They started out as a retail storefront, and that culture is still in the company. AWS relies heavily on modules. They didn't originally. Why do they rely on modules? Well, they didn't do what Microsoft did. Microsoft rewrote their plugins multiple times until they got it right. AWS has not rewritten their plugins. When I first prepared for this course, it was a painful weekend when I didn't want to use the modules. I wanted to have the control, but I had to write so much more code and I had to have so much more complexity. And the modules have already taken that complexity out of it. But it does mean that I'm constrained to what the module expects. And it does mean that I have to suffer through and I have to actually read the code and figure it out, how the module works. Because I'm not going to give them a dime in professional services. CSP modules are updated without notice. This is something about DevOps that I don't like. Case in point with Terraform, I have every version going back to 0.34 on my development desktop, and then I back that desktop up to a hard drive. Because I can only get the most recent Terraform code when I download it. And that annoys the crap out of me. Because I still have some clients that are running 0.x, and I still need to stand that up. I understand why this is being done. This is being done because it's expensive to support all those versions. And so we need to go faster, we need to go cheaper, and that's part of it. However, as we have more and more lines of code running our applications, there is the risk of defects leaking through without notice. And so one of the things we'll talk about is pinning your versions. And one of the things you'll come to appreciate with Azure DevOps is if Microsoft is not comfortable with the latest and greatest that HashiCorp is pushing out, they're not going to make it available in Azure DevOps. I like that. So always pin your modules, always pin your versions of the plugins. It's the right practice. But what it does mean is the responsibility is on you when you pin it to later go in when you do some new work and up it and see what happens. And that adds time to your work, but that's just being a responsible developer. If you're not doing that, then it won't take long before your stuff doesn't work anymore, and then your boss is going to come looking for you, and it won't be pretty. Always clone a copy of your module into your into your GitHub account so that you have it. You don't want to have it just sitting on your desktop. That's a bad thing. Because what if you, as a leader of a development team, follow through with that kind of practice yourself, and now a colleague learns a bad practice from you, and now a new version of the module came out and only one person had it, and that person poured coffee on their laptop. Oh my goodness, not good. I will tell you that large file support must be enabled because the modules are big. And what is large file support? Well, first of all, it's a PIA, but secondly, what it really is technically is it's a VM that runs in your infrastructure, either in cloud or on-prem. I prefer in cloud, of course. And what it does is it has stubs that it writes to the actual Git repo that reference where the larger files are. Spot instances will get you in trouble in AWS because they're not always available. And I can bet you during business hours, they're almost never available. Spot instances are cheap. They're good weekend play stuff. Don't use them when you're developing. Just pay for it and get the capacity that you need to get your work done. It's kind of ugly when you run a declarative, when you're running a declarative language and your pipeline, your release partially builds because there weren't spot instances available. Especially in AWS, because things take longer to build in AWS than they do in Azure and OCI. I don't know why that's the case, but you'll see that it takes about 15, 20 minutes for this cluster to build. And there's nothing worse than going down the hall to get the cup of coffee and to come back and to find out that your release failed because you used spot instances. Specify a minimum on-demand value, and we're talking AWS here, minimum on-demand value of 1 to get your cluster built. 0 is assumed. What the hell? And specify spot allocation strategy for capacity optimized, prioritized. I had some screaming on that one. You know, sometimes we need to be in the padded room as developers. So avoid that. You may need to play around with availability zones because sometimes in AWS, the capacity is not there when you expect it. And so you could build that logic in Terraform. That's really difficult to do in a declarative language. And when we go back to the things that I don't like about AWS, that's one of the things I don't like about it. And that's core to how they have built their technology. But you culturally and politically may not have a choice. You may be running on AWS. And that decision may have been made in the chancellor's office. So then you got to deal with it then. Okay, you may need to play around with your VM sizing to find the right capacity that's available. This gets back to this basic issue that I find exists from time to time in AWS, and it's annoying. This is important. Perk up. You need to protect the Terraform state file. If you lose the Terraform state file, the most painful thing you can have to do is to have to re-import it from the existing cloud infrastructure. Furthermore, the Terraform state file, you may all be using the same Terraform state file, but if you have different credentials, then your Terraform state for the same infrastructure that you're trying to manage, that your colleague is managing 2 desktops down, it's not going to be the same. Oh, man. What does that mean? That means in AWS, you're going to set up a service user that does not have login privs, that uses API keys only. And you're going to manage and secure those APIs with the greatest of care. Because a failure to do so means that if you will no longer possibly be able to manage that Terraform infrastructure. And when you're talking about thousands of objects, oh, that's just ugly. And there are things that you will not want to Terraform. For instance, when I'm building on an Azure, I like to do it at the resource group level, where I've got a resource group or a container in OCI, and I forgot what AWS calls it. A resource group is just a way to organize your cloud resources. And so I start with the resource group. The resource group is tied to a region. And then my VNet is the first thing I build, your virtual cloud network, or whatever you want to call it. And so everything that I build in a resource group is managed in the Terraform state file and the Azure service principal, that's the credentials, that owns that Terraform state. What I won't do is I won't peer that VNet using Terraform to other VNets. I'll do that using Azure CLI or the portal, because I don't want to have the code to be that big, because now I may have this one ancillary application and it does something for financial aid. And it came on after Banner was built in the cloud. And now I've got to account for a very large batch of code with a lot of complexity. That's ugly. Because if you get it wrong, you'll break production. And nobody wants the president and provost and CFO showing up at your desktop. Look up and there's the CIO. Oh, wow, I feel really unhappy now. No, you don't want that. Remember, in DevOps, we want our batches to be small. Why? Because if we break something, we can find it quickly and fix it. And the scope of the risk of change is reduced. That also means we have changes that are constantly happening in our organizations. The change advisory board, that needs to be slashed. My research paper talks about that. It moves into something else. There are things you won't want to, there are things that you need to consider with that, but back to the Terraform state file, you need to protect that, and you need to version it. So in Azure, I use an ASR, or say I use an Azure Vault for blob storage to protect it, and I go back 90 days. And it is, it's actually using the underlying storage account replication. This is something that Azure is very strong at. In OCI, I don't know the answer to that, because I haven't done this in OCI yet, as far as backing up Terraform state or blob storage specifically in OCI, but it's just a programming problem. There's a solution to it. And AWS also has tools to back up the storage blobs. So you want to at the storage account level or at the storage bucket level, you want that to be a geo-replicated bucket. But you need to have version snaps. That's what it really is. That's what it's called, is a snap. So that if there's an error on the part of HashiCorp, or somebody fat fingers the file, you can get it back. And you should practice that in your sandbox subscription. You remember in the very beginning we talked about needing 2 subscriptions? You got to have at least 2 per cloud provider. So within the blob file that gets created, there's a key file where the states are stored. And we talked about 2 users having 2 different states. It's perfectly fine in the sandbox to do Terraform development with your local credos from your development workstation. But when you do the push, you're going to have to do the push using the service account. In Azure, we call that the service principal. In AWS, it's just a user account, but you don't enable remote login capabilities. Matter of fact, except for very few accounts, no one should be logging into AWS with a password. It should all be done with an API key. Never build production managed Terraform infrastructure from a Terraform state file that is on your desktop. That's a resume writer. I've got a developer that I'm still trying to get him to understand that this is not the right way. And now at this point, I'm forcing him. I'm saying, you will not build it this way. You will destroy that and you will rebuild it using Azure DevOps, using the service principal. Okay, so, and you need to define your processes and controls. You have to have the guardrails. GLBA requires this, that we have evidence of policy and standards. And that gets back to the NIST standards. 800-171 is the predominant one, 5.3 if you're doing healthcare. If you're not doing healthcare, 171. So we're going to take a break.